So this Vsphere theory, the full form for Vsphere theory is valence shell electron pair repulsion theory. It is valence shell electron pair repulsion, valence shell electron pair repulsion theory. So the main objective behind this theory was to explain the shape of the molecules. The main perspective was to explain the shape of the molecules. And what molecules? Obviously the molecules, that means we take into consideration only covalent compounds. We take into consideration only covalent compounds because they only have the proper shape. Otherwise the ionic compounds, they have the lattice, they are properly arrangement in the three-dimensional space, we know that. So it take into consideration only the covalent molecules. So now what actually this theory, what it wants to explain you. So before explaining you, I just want to tell you that I'll be taking an example, then I'll correlate that example with the postulate of this theory, right. So just look at the board first. Suppose I have got two balloons. I have got two balloons. Why I am taking balloons? Because I am you can say correlating the balloons with the electron cloud. I told you that when atomic orbitals combine, they form a molecule. So what I am doing is I am just you can say looking at the similarity between the electron clouds of the atom, the valence electron, and as well as the balloons. So what happens if I am going to take two balloons and I am going to tie with a thread, they will somehow acquire this kind of shape, right. And if I have three balloons and I am going to tie them, so what kind of shape I am going to get? Obviously I am going to get this kind of shape. Now if I say I have four balloons and I need to tie them again with a thread, then what shape I'll get? I'll get this shape. And if in case I have 5 balloons and I need to tie them, then 2, this is my 3, this is my 4, and this is my 5. So similar to this, the arrangement I'll get. And if I have 6 balloons and I'm going to tie them, then I'll get arrangement like this, right. So similarly we have seen that the electrons actually you can say we can compare the electron cloud, we can just you can say relate, relate will be the correct word, that we can relate the electron cloud of the atomic orbitals with the balloons. So the atomic orbitals combine, when the atomic orbitals combine, they form a molecule. So what kind of combination do we get, or what kind of shape, or what kind of you can say shape of the electron cloud which we see is just similar to this thing. Now we are going to start with the postulate of Vsphere theory, that what actually Vsphere theory states, that what is the statement given in accordance to the Vsphere theory, that it helps in finding the shape of the molecules. So the first postulate is that it says that it take into consideration only the electron pairs of the valence shell, right. So it says that electron pairs of the valence shell of combining atomic orbitals interact with one another. Obviously see that if there is one atomic orbital and one atomic orbital, they are far apart, right. So there won't be any interaction, but when they will start approaching each other in order to combine, so obviously they will interact with each other, they will interact, and obviously the interaction will be, so the Vsphere theory says that the interaction is mostly it is between the electron pairs of the valence shell, electron pairs of the valence shell and those of the combining atomic orbitals. Now if we look for the what kind of interaction, attractive or repulsive, this must be striking in your mind, that interaction means they want to come closer to each other, or they just want to move away from each other. So as we know that the same charges repel, so obviously the electron pairs of one atomic orbital and one atomic orbital must be of same charge, right. That means both will be a negative charge. So obviously they will repel each other. They will repel each other. And now we know that like if they will repel each other, repulsion leads to increase in energy. Repulsion needs to increase in energy, and we know that energy is considered as a stress. That means more is the energy, less is the stability. And like if the energy won't be lowered, if the stability won't be there, then how atomic orbitals will combine to form a molecule, right? So that means we need to minimize that energy. We need to minimize that energy, and that energy can be minimized only you can say when it will lead to an attraction. So what happens? It says that valence electrons repel each other, right? It's correct because they are of same charge. Now what they will do, the atomic orbitals, or you can say a molecule containing the atomic orbitals, it will orient in space. That means it will take us, the electron clouds will take a certain preferred direction in the space, and in what ways? It will do it in a way in which the electron pair are maximum apart. That means electron pairs are just maximum apart. And why they are maximum apart? Because the distance is, you can say, when the distance will increase, the repulsion will decrease. And when the electron pair distance will increase, likewise, they will get the reduced repulsions, or you can say we will get the minimal repulsions. So that now if you look for the repulsion strength, as we know that we have two, like we have the electron pairs, this thing divided into two categories. One is the bond pair, other is the lone pair. Bond pair is the one which take part in bond formation, and lone pair is one which do not take part in bond formation. Like I'll explain you. Suppose if I have an oxygen molecule, I say it bonds to it like this, right? So this is a bond pair, and these electrons are not actually participating directly, right? Because they are somehow you can say included in the octet, but they are not being shared by some other atom, right? So that means they will be considered as a lone pair. They will be considered as a lone pair. So the one, the pair of electron which is taking part in bond formation, they are bond pairs, and the one which is not taking part in bond formation, they are considered as lone pair. So obviously the molecule is going to have, like this molecule has a bond pair along with the lone pair. So obviously any molecule, if you take into account, will possess the bond pair as well as the lone pair. So if we talk of the repulsions, like if we talk about the repulsions, we will see that the repulsion between lone pair and lone pair is the maximum. Repulsion between lone pair and lone pair is the maximum, and the lone pair bond pair is less comparatively, and the least one is the repulsion between bond pair and bond pair. Because we need to take into consideration these interactions, very important, because if we will not take into consideration, then how we'll come to know that yes, this geometry is going to distort in this manner, or this molecule, or you can say the atomic orbitals will move more far, they need to be more separated. We'll obviously we'll come to know only when we know about the repulsion strength. So this is very important factor. So I think you got the VSEPR theory. So first it states that it takes into account only the valence shell electron pairs. Keep in mind, I'm not talking about the inner shell electrons, I'm not talking about the nucleus, I'm just talking about the electron pairs of the valence shell, right? Second is that when atomic orbitals come closer to each other, there is an interaction. There is an interaction. Now the interaction can be attractive or repulsive, as we know in general that interaction is attractive or repulsive, only two factors we have, right? But here what we see that interaction is repulsive because they possess the same charges, right? Third, so because of the high repulsions, the energy will obviously increase and the molecule is going to be unstable. So that means what we need to do is, we need to separate atomic orbitals such that in a space such that the distance increase and the repulsions minimize. This is what we are doing. Like we'll try to draw a molecule geometry, we need to take these things into consideration. And fourth is that if we take into the account the repulsion strengths, so obviously lone pair repulsion is maximum and bond pair repulsion is least, and the moderate one is the repulsion between lone pair and bond pair. So these are actually the postulates. Now I told you about these balloons, like my criteria behind explaining you this balloons arrangement was that we actually consider the atomic orbitals as, or you can say electron cloud as this kind of shape. So we say, like suppose these two atomic orbitals are combining with each other, right? So when they are combining with each other, so obviously they are going to repel each other. So obviously we are not going to keep it this way. We won't say that it will acquire this kind of shape, because here what is going to happen, these atomic orbitals will be closer to each other and it will be more repulsion, more energy and least stability. So that means if we have two atomic orbitals, then they need to combine. So what kind of geometry actually they will tend to obtain? they will tend to obtain this kind of geometry, right. So let's see this, so they will acquire this kind, so that they are maximum apart and the repulsions are minimum. And like suppose we have you can say 3 atomic orbitals are combining, then they will acquire this kind of geometry. See, they are far apart. This is the maximum distance we can create between them. And if they are 4, then it is again this thing, this kind of arrangement. And if they are 5, the arrangement is this. And if they are 6, the arrangement is this. Means this is, you can say, a proper geometry what a molecule will attain if it carries the atomic orbitals, because due to the repulsions actually. And one thing I want to make you familiar with, that in each of these balloons I haven't considered the lone pair. I have taken into consideration only the bond pair, right, because as we know that if the molecule possesses the bond pair, geometry is something else, and if it is going to possess the lone pair, obviously geometry will be something else, and if it is going to possess more than one lone pair, so obviously the geometry is going to be something less, because we know that actually the repulsion strength decrease in this order, right. So we need to take into consideration that whether the lone pair is present, lone pair bond pair is present, or bond pair is present. So this is what actually VSEPR theory is trying to explain you. Now we are going to start with the shapes of the molecules, just depending on the VSEPR theory, taking into consideration all the postulates and even the balloons arrangement which I told you, right. So just look at the board carefully.